This video is going to be about finding the inverse of a matrix. And there are a few ways to do this, but what I want to do is show you a nice method if you've got a small matrix like a 2 by 2. This is going to take a little bit of time, but it's kind of a neat method. So here I've got a 2 by 2 matrix. It's 3, 4, 2, 3. And I'm looking for its inverse. Now its inverse would be the matrix I could multiply it by and get the identity matrix. So I'm going to make believe I know what it is, and I'm going to put an empty box after it, an empty matrix box. And if I knew what to put in that box, I could multiply it by my original matrix, I would get a 2 by 2 identity matrix. That would be 1, 0, 0, 1. Well, in algebra, when we don't know what something is, we usually give it a letter. So I'm going to take this second matrix and fill it in with letters. I'll fill it in with A, B, C, and D. And now I've got two matrices. They're both filled in. So I'm going to multiply them together, and they will equal the identity matrix. So here we go. If I multiply the first matrix by the second matrix, and I want to get the element that's in the first row, first column, I'll multiply 3 times A, well, that's 3A, plus 4 times C, so that's 4C. Then for the first row, second column, I'll multiply 3 times B, 3B, plus 4D. Going down to the second row, first column, I'm going to have 2A plus 3C. And then my last element, second row, second column, is going to be 2B plus 3D. And so now I've got the product of those two matrices, the original matrix and what I made up with just letters as its inverse. And so that product should still equal the identity matrix. Now, if I've got two matrices and they equal each other, that means the elements in corresponding positions will also equal each other. So whatever I've got in the first row, first column of this new matrix should equal whatever's in the first row, first column of the identity matrix, which is a 1. So I'm just going to write that out. I'm going to say that that thing in the first row, first column, which is 3A plus 4C, equals 1. And now if I go to the second row, first column, I've got a 2A plus 3C, and that would have to equal 0. Well, what I've got here now is a system of two equations with two unknowns, so I can solve this system and find out what A and C are. So to solve that, I'll take the first equation and multiply it by a 2. I'll take the second equation and multiply it by a -3. Multiplying those out, I'll get 2 times 3A is 6A, plus 2 times 4C is 8C, and that's going to equal 2 times 1, or 2. Then for the second equation, -3 times 2A is -6A, -3 times 3C is -9C, and -3 times 0 is just 0. So I can add those two equations together. I've eliminated my A's, and I've got an 8C and a -9C, so that's -C equals 2, so C equals -2. Okay, so the first thing I'm going to do is put that -2 into my matrix where I had a C. And now I can find out what A is. I'll take that -2 and plug it into one of the equations I had. So why don't I plug it into this 2A plus 3C equals 0. So 2A plus 3 times negative 2, that's 3c, equals 0. So 2a minus 6 equals 0. So 2a is going to equal 6. And then dividing both sides by 2, I get a equals 3. So I can go back to my original inverse matrix where I had A's, B's, C's, and D's, and instead of the A, I'll put in a 3. And now I'm going to do the second process for two other equations. So let me just make some room here. I've got these two equations. I've got 3b plus 4d, and that must equal 0. So 3b plus 4d equals 0. And 2b plus 3d must equal 1. 2b plus 3d equals 1. So once again, I've got a system of two equations with two unknowns. I'll multiply the first equation by 2. I'll multiply the second equation by negative 3. And that will eliminate my b's. So let's see. 2 times 3b is 6b. And 2 times 4d is 8d. And 2 times 0 is 0. Negative 3 times 2b is negative 6b. Negative 3 times 3d is negative 9d. And negative 3 times 1 is negative 3. Okay, adding those together, my b's get eliminated. I've got an 8d minus 9d, that's negative d. And negative d is going to equal 0 minus 3 is negative 3. So d equals 3. I'll plug that into the inverse that I'm building. And now all I have to do is find b. So I can find b by substitution. I've got d equals 3. So let's go to this equation, 3b plus 4d equals 0. 3b plus 4, well, d is 3. 4 times 3 equals 0. So 3b plus 12 equals 0, which means 3b equals negative 12. And then b, dividing both sides by 3, b would have to equal negative 4. Okay, so b is negative 4. So it looks like I found my inverse. My inverse should be 3, negative 4, negative 2, and 3. Okay, so we can check this. Let me erase what I have here, and I'll just multiply these two matrices out and see if I get the identity matrix. Okay, I think that's enough room. Okay, so let's see. I'm going to have 3 times 3 plus 4 times negative 2. Well, 3 times 3 is 9. And 4 times negative 2 is minus 8. And then for the element in row 1, column 2, I'll have 3 times negative 4, which is negative 12, and 4 times 3, which is positive 12. In my second row, for the second row, first column, I'll have 2 times 3, which is 6, and then 3 times negative 2, which is negative 6. My last element will be 2 times negative 4, that's negative 8, and 3 times 3, which is 9. And that's all supposed to equal the identity matrix. I'm going to put a question mark over the equal sign until I'm sure it works. And then let's see. So 9 minus 8 is 1. Negative 12 plus 12 is 0. 6 minus 6 is 0. And negative 8 plus 9 is 1. And that is, in fact, my identity matrix, 1, 0, 0, 1. So this matrix that I came up with, the inverse 3, -4, -2, 3, seems to work fine. Okay, so once again, the process I used was this. Since I didn't know the inverse matrix, I just made one up with an A, B, C, and D. Then I multiplied the two matrices together. That gave me two systems, or two systems of two equations. I solved each of those systems separately and found out what my A, B, C, and D were, and that gave me my inverse matrix. I checked it by multiplying the original matrix by the inverse matrix. Okay, so that's the whole process. It's a bit of work, but it's kind of an interesting exercise, so you might want to try it. That's it for now. Take care. I'll see you next time.